This is a recording of my conversation with Ralf Klinkerberg, one of the founders of RapidMiner, a leading data science platform. I asked Ralf what is artificial intelligence, data mining, deep learning, and data science. What are the applications in business and the success factors for companies implementing AI? We end with what is the potential of AI for society and business. I'm talking to Ralf Klinkerberg, one of the founders of RapidMiner. Ralf has more than 25 years experience in data science and started RapidMiner almost 20 years ago. RapidMiner is one of the global leaders in data science software platforms. We'll let Ralf introduce himself and RapidMiner. Ralf?
Thanks for the kind introduction. My name is Ralf Klinkerberg. I'm one of the two founders of the company RapidMiner. Also one of the three founders of the software platform RapidMiner. We started RapidMiner as an open source project in 2000. So like you said, 20 years ago. In the beginning, it was not a commercial project. It was a tool that we built for ourselves because the tools we found in the market were not flexible enough for what we wanted to do. And then we made it open source so more people can use it. And then after a few years, companies started using the software and started to ask us for services. If we did consulting, could help them with project. And then we decided, well, maybe we should try that as a company as well. And then 2007, Dr. Ingo Mierswa and I decided, let's try it. We will start a company. If it works, we'll do it. If not, we'll decide after a year to stop the experiment and do something else. Turned out the first year was quite successful. We already hired our first employees. And we continued the company. It's grown from two founders to more than 100 people today, and the growth is still going on. It's quite an exciting story.
It's a great story. So before we talk more about you and RapidMiner, I'd like to start with some fundamentals. So what are data science, artificial intelligence, machine learning, deep learning?
It's a very good question because, the understanding of those terms is not so clear usually. Let me start with the broadest term that is used so much nowadays, AI, artificial intelligence. What's that? From my point of view, it's everything that seems intelligent from a human point of view. If you think back, like hundreds of years ago, people who could compute with big numbers, they seemed intelligent. So if a machine would be able to do that, that would have been considered intelligent. Then we had calculators. Nobody thought that's intelligent anymore. If a small box can do that. So then chess playing was considered intelligent. But then we have computers beating the best chess players. So people say, well, this is just a search. It's complexity that a computer can handle. So it must be something else. So in that sense, intelligence is really a dynamic term from my point of view. What you consider intelligent in a human and a machine changes over time. So my definition would be something along the lines, intelligence is something that we consider intelligent in a human and that being achieved by a machine if we talk about artificial intelligence. So it's a bit of a vague definition because strictly speaking, a machine learning algorithm or an AI algorithm is a mathematical function, is something or a program that can be expressed in mathematical terms. So is that really intelligence in a human way? You can argue about that. So I'd rather stay with the vague definition. If it's something that seems intelligent to us, we call it intelligence, and that's AI as we understand it today. But I'm pretty sure in 50 years, people will have a different understanding what intelligence really is than what we have nowadays. Machine learning is a bit easier to grasp. One of the most important aspects of intelligence, obviously, is learning, is the ability to adapt to a changing environment. And machine learning can be defined as learning from examples. You have data from the past, observations from the past. You try to find patterns in the data that you allow you to give explanations to things that happen that allow you to do predictions. And attached to that is another term called predictive analytics. That's a kind of machine learning or data mining that you do to generate models that allow you to predict the future, certain outcomes, like, for example, predict machine failures before they happen or predict how likely a customer will churn or not churn. Then there's a certain class of learning algorithms called neural networks. They try to mimic biological neural networks. Neurons are nerve cells, like we have them in the brain, and the whole network of such cells can be also modeled in a mathematical way, and then it's called artificial neural network, or in short, just neural network. And they've been around for a couple of decades already. There was a big hype in the 1990s, but now in the recent years, the computer hardware has become much more powerful. Also, the algorithms have advanced more. So now there's a subgroup of these neural network algorithms that is called deep learning algorithms, because they can solve more complex problems. They partially also solve some of the data pre-processing. Like in earlier days of machine learning, was more important that humans had to think about how to prepare the data so the algorithms have a chance to find the patterns. Now the algorithms become stronger and can do some of that, let's say, low-level data, raw data understanding by themselves without pre-processing. And they quite successfully apply, for example, in image analysis, image classification, handwritten character recognition, things like that. But they are not the best solution for everything. There's problems when you have a lot of data, and these types of problems that work quite well. But if you only have very small data sets, then there might be other learning algorithms that are more powerful. So now I still have to explain one term, that's data science. The name also suggests it's about data, analyzing data, trying to create value, insights from data. And you can leverage machine learning to do that, but you can also use your own brain to do that. So that also would cover interactive analysis of data. For me, it's all kinds of data analysis, be it human, interactive, automated, semi-automated, to create insights and value from data, using obviously scientific methods from math, statistics, computer science, and so on. It covers also aspects of data handling, data storage, data preprocessing, data cleaning. So it's not just about the modeling like in machine learning, but it covers the whole process. And typically it also includes the deployment side. I mean, once you have a model that has a high accuracy in predicting things, you obviously want to use it in production. How do you do that? And there's a lot of ways how you can do that. Maybe make it available in an interactive web app so the end user can interact with the models, or fully automated in a web service or some other kind of process automation.
Thank you for the very comprehensive and clear explanation. What attracted you to the space, and why did you start RapidMiner?
Yeah, my interest in machine learning actually started 10 years earlier in high school. I was already quite a computer science nerd. I really like creating programs that can solve problems. Like as a human, you have to solve the same problem again and again. What I liked about computer science, you basically tell the system once how to solve the problem, and it does it again and again. So you could say it's out of laziness that I love computer science. And then I very quickly became interested in machine learning, because I was interested in what is intelligence, what's learning, how does it work in humans, how can you make machines smarter, how can you make machines learn. So I implemented my first neural networks in high school in 12th grade. And then when I studied computer science, my focus was very quickly on machine learning and AI, because of that interest in understanding how things work, seeing what algorithms are available, not only for machine learning, but also knowledge representation, knowledge reasoning, fuzzy logic, controlling, all these things. And then, yeah, like after some years of research also, Ingo, Mirsma, and myself, we realized the tools out there are not flexible. We're kind of redoing certain things again and again, like implementing data transformers between data sets and algorithms to compare different algorithms, or if you have a new algorithm, you have to compare it to the state of the art, and then you start to doing things that you have already done before in one way or the other, or that someone else has done before. And we felt that's quite inefficient. We want to have something like a Lego toolbox where the state of the art is available, and all you need to do is add your new building block, and then you can combine it with everything else. You can compare it with everything else. So from a research perspective, be able to innovate faster, to validate faster, compare faster, and to have a system that would allow you to grow. Like every new approach would be added, but you can already reuse what's out there. And we started that as an open source project in the year 2000. And then when we made it open source, we started to have some universities using it, and then companies started picking it up, and then they started asking us if we do consulting and things like that. And at some point we said, okay, what do we actually do after university? And then we decided, let's try it. So that's how I made my way to machine learning into starting RapidMiner.
So let's discuss about some of the applications, some of the practical applications that you have seen over time, RapidMiner being used in various industries.
We see a lot of applications in the manufacturing and production industry, in automotive, aviation, chemical industry, pharmaceutical industry, and so on. And then the most prominent use case there is called predictive maintenance. It's predicting machine failures before they happen, so you can prevent those failures from happening. It makes your whole process more plannable, more reliable, and reduces cost. So that's actually a primary driver of data science in the manufacturing industry. Another big area is, of course, customer analytics. like things like direct marketing optimization, whom to send what kind of advertisement to increase their chance of buying something. Customer churn prediction, predict which customer is going to cancel the service or not buy the product anymore, try to prevent it by making a custom-made offer. Automated product recommendation, like we know it from Amazon. You can do that for all kinds of products or services. There's something called next best action. Let's say you have a customer, you have someone at the point of sales talking to the customer. What should he recommend to the customer? What does the customer need? What is he most likely to buy? Demand forecasting. For example, we work with one of the biggest book retailers. They give the promise to the bookstores. The customer comes to the bookstore. They don't have the book in store. If you order it until 5 p.m., you'll have it delivered by 9 a.m. the next morning. To be able to do that, they have to forecast for each book title what will be the demand in what region, so they can have those in store as a book retailer. Then there's something called cross-selling. If a customer has a certain product selected, let's say a digital camera, what could you recommend to him that would be useful addition? For example, additional batteries, a memory card, a camera bag. There's a lot of ways how you can optimize your revenue and your profits. It includes also optimizing portfolios. Like if you're a retailer, online or offline, what product should I have in store? What should I offer? How should I present it? So together with PayPal, we did a use case where we analyzed the customer feedback of customers from 60 different countries in more than 30 different languages to automatically determine for each customer feedback what's the sentiment, how likely is the customer to churn. And then we aggregated that to find out over all customers what are the most critical issues. So there's a lot of applications in various areas. I could go on and on, but I don't want to overstretch your time.
Thank you very much for the great examples. So what do you see from the companies that are successfully now embarked on the data science, using data for their management decisions?
It starts with a certain mindset that you understand the value of data and that you also have a certain mindset in doing a data science project. First of all, it starts with the data. If you have no data, the machine learning has no grip because there needs to be data from the past for obviously predicting things, for learning patterns in the data. Data quality often is an issue, but it's not only the data quality in sense of, oh, the sensor is broken, the readings are wrong or something like this, but also quality in terms of, do I have data silos that cannot be connected, or do I have a chance to connect the different data sources across the whole product lifecycle? It's also important to have an iterative approach or an agile approach. Fail fast if there's no possible solution, and also iterate, like start quickly, come up with initial solutions quickly to see how they are, give feedback to the data scientists, interact with domain experts to have different views on that. Does the model make sense from business perspective? Does it make sense from a domain expert view, like who knows the physics and the machinery? Does it make sense from a data science point of view? And then iterate until it's good enough to go into production.
Final question, and it's a big one. So what do you think is the big potential for artificial intelligence for businesses and society?
Yeah, that's really a big question. First of all, it's about understanding the world better in a sense. And the world can be how society works, how nature works. If we think about climate change, can also be about how my business actually really works in a data-driven way, not just an intuition way. Using data mining, data science, machine learning to gain insight, understand correlations, understand causal chains of things happening, but also forward-looking in the sense of predicting opportunities to be better able to leverage those opportunities. Can be the cross-sell thing in a retail sense, can be there's a potential new customer opportunity, predicting risks and avoiding them, for example, predicting machine failures to avoid them. So in general, it can help us to make governments, societies, organizations, companies more insightful and more efficient, to make them more forward-looking, more successful, avoiding risk, leveraging opportunities.
Thank you, Ralf. This was very interesting. Thank you very much.
Thank you very much for having me.